Okay, so your base will never be 1. This will never happen. And I'll kind of show you why. If your multiplier is times 1, think about it. If I have 3 times 1, that's 3, times 1, that's 3. That's not growing or decaying, it's just staying the same. So you'll never have the same number multiplying over and over again. All right, so what I'm going to show you is how to write an equation if you have a linear function and how to tell the difference between a linear and an exponential. All right, so here we have two functions. So if we look at the linear function, notice how my x's are going up by 1 each time. You don't need me to write it out for all of them, but you can clearly see. And now if we go from 4 to 6, I'm adding 2. I'm adding 2. To get from 8 to 10, I'm adding 2. So my average rate of change is constant. Okay, it has a constant slope. So in this case, rate of change is the same as slope. Okay, and so again, a quick review is y equals my slope. Now remember, slope is change in y over change in x. So change in y over change in x, right? So 2 over 1 x plus my y-intercept, which in this case is 4. All right, so my final equation would be 2x plus 4. All right, nice. So when you look at the exponential, you can kind of see, again, these guys are going up by 1, which is cool. But what's happening here is, okay, I could say, oh yeah, this is going down by 20. But then this guy is not going down by 20, so it's not consistent. Or constant, I should say. So what's happening here? All right, let me think about this. To get from 40 to 20, I'm dividing by 2. Oh, half of 20 is 10. Half of 10 is 5. Half of 5 is 2.5. So that's definitely where I'm going to start. So that's why you know it's an exponential. And that b is what you're multiplying by. So when you're dividing by 2, that's the same thing as multiplying by a half to the x. But now I still need that a. That a represents my starting point, my y-intercept. So again, you're looking at the 0. Okay, and so my starting point is 40. So if you were to type this in on the calculator to graph it, you would type in 40 times parentheses 1/2 to the x in the exponent. All right. So linear functions, I think you can see that here, are based on repeatedly adding or subtracting the same amount. And when you're looking at exponential functions, you're looking at you're repeatedly multiplying or dividing the same amount, okay? But with exponentials, if we're going to do division, we just multiply by the reciprocal. So instead of saying divided by 3, we would write that you're multiplying by a third. That means the same thing, all right? All right, so what I'd like for you to do, I'm going to label these A, B, C, D, and E. And I would like for you to decide if they're exponential or linear. You don't have to write the equation. Just decide, are they exponential or linear first? And then we will try to write the equations. Okay, so let's see. From here to here, if I go from 5 to 15, that means I'm adding 10, right? And then from 15 to 45, I'm adding 10 again. Okay, so since it's going to be exponential or linear, and I can't add 10. So it's definitely not linear. So that means he's exponential. So the formula I'm going to use is y equals a times b to the x. A is my starting point, so that is 5. All right. Now, what am I doing to get from 5 to 15? Oh, I think I'm multiplying, right? 5 times 3 is 15. Hey, 15 times 3 is 45. 45 times 3, yep, that's 135. So there's my equation. That's my multiplier. All right, let's try this guy. These are all going up by 1, so that's good. Let's see. From 7 to 4, that was down 3. From 4 to 1, that was also down 3. From 1, yes, he is linear. So that's my y equals mx plus b formula. So y equals, I'll do my plus b first. That's easy. It's 7, right? And since my slope is down 3 over 1, I'm just going to write minus 3, and I need the x. See how fun these are? So I would like for you to do C, D, and E on your own, and I will see you in class.